Today's discussion is regarding algorithms and flowchart. It's very important for every one of us to understand what do you mean by algorithm, and can you we have already seen this. What is an algorithm? It is step-by-step procedure which is written in any English-like language, which helps you to lead to a proper output or proper program. Okay, so that's what we are going to discuss today. The depth of it, how to write an algorithm. It's a very basic discussion, but mind well, this we are going to see only algorithms in this entire subject. Entire subject. Okay. So in the last lecture, we have seen what do you mean by problem solving. Problem solving is defined or divided into two parts. Problem solving phase, where we are first writing a step-by-step sequence or procedure which will describe the approach towards a uh, solution of the problem. Okay, that is called as an algorithm. This is most crucial stage which will definitely help you to write a perfect program. If this algorithm is absolutely correct, then you need not to really worry um, about coding. You can simply convert that algorithm into any programming language code. So the problem solving phase is an important one, which we have already seen in the last lecture. And these are the steps. First, you'll write a small pseudocode, and then you'll convert it into a very fine algorithm. And finally, you are going to convert it into a program. So what is this that we are going to see next? How a program is written. In the earlier lecture, we have seen what is the first step we are supposed to define. Can you prompt? What is the first thing which we are supposed to define when we think of writing a program? You please prompt in the chat box, or you can put your mic on and answer. What is the first thing we will think about when we
Initially, we need to define the
define a
problem.
problem? Yes, Aditya, please repeat.
So initially, we
You
need to
people are.
define the problem.
Am I audible? Yes, understanding the problem, defining the problem. Yes, once we have defined the problem, then we are supposed to write a program. Okay, once we have defined a problem, we are supposed to write a solution or a program for that. So, what will be our first thing after definition of a problem? Our first thing will not be rather defining a problem. Defining problem, definitely it is identifying a problem. Chirag is saying algorithm. Anything else you can think of? Data we need to provide. Karan, yes, someone answered something. I could not hear. Someone answered on the mic, but I could not hear. Right, data which we need to provide. The first thing which we need to go for is input and output. Right, the input which you are going to provide. What will be the inputs to the data to get the solution? And solution is in what form you need the solution is the output. So first thing we need to consider is input and output. Along with that, defined solution. This is the way I am going to define a solution that is needed. So this is a logical level of understanding a program. Once we are clear with input and output and the solution which we are approaching for, we can have a pseudocode. That will be the first stage we are going to write. Pseudocode is written in English or any other language which you understand. Okay. Then we convert that pseudocode in little fine algorithm. That fine algorithm really gives you every step of it. It is a detailed pseudocode or detailed steps which are leading to a solution. Once we are done with algorithm, we are supposed to define the flow chart. What do you mean by flow chart? It's a diagrammatic representation of the algorithm, how the controls in the program are going to uh, move. And lastly, we'll write the program. Okay, lastly, we'll write the program. And this program is nothing but called as source code in our computer terminologies. Okay, so these are the steps which will lead you to the solution, lead you to the source code. Fine. So again, I am repeating, programmer will just convert the algorithm into a program, but an engineer is going to think about all these things, where we are going to provide a solution right from the scratch, defining a problem, understanding it, making the inputs and outputs, define, then writing a pseudocode, algorithm, flowchart, and a program. Okay, so source code is written in this way. This is a very important step, and most of us skip all of this and we directly start writing a program, which is not good. Okay, so this way you can define a source code. Then what is an algorithm? Is it okay? Is it clear? Whatever I just now said? Good. Now we will define an algorithm. There are different definitions of algorithm. See, you understand, algorithm we are not writing only for program. Algorithm we can write for anything, anything. Simple logic you can understand that if I am going out today, I'll go out, I'll see if it is cloudy environment, there are chances of being rain. So I should keep my umbrella with me. Okay. Or if it is shiny, then there are less chances of rains, then I'll avoid carrying an umbrella. So that is also an algorithm. Any real-time situation can be an algorithm. You are starting from your place and coming to the college, deciding how to go for. If you have a vehicle available, then you can come by your own vehicle. If you have your friend with you, you will better share the petrol with him. You can opt for bus, you can opt for city bus, anything you can opt for. So for any situation, you can write a program, write an algorithm. Hence, as per dictionary, algorithm is defined as a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. Okay, a process or set of rules to be followed in calculation or other problem solving operations. We are computer engineers, we are specially mentioning especially by a computer. This is a definition of an algorithm as per dictionary. But for programming, it is written in some little modified way. An algorithm is a procedure or step-by-step instructions for solving a problem. They form the foundation of writing a program. These instructions, which will solve the problem, basically form a foundation of writing a program. With the help of this, we can write a program. For writing any program, following has to be known. What has to be known? The input and the task to be performed. It is little mismatched. So, and the task to be performed. So these are the two things are needed. So we will stick to the second definition because we are more bothered about programming. So we'll stick to the second definition of algorithm. What are the characteristics of an algorithm? What are the characteristics of an algorithm? See, while writing an algorithm, we must understand it should follow few aspects. First one is definiteness. Definiteness means it says that definiteness. Algorithm should be very clear and unambiguous. Unambiguous. It should give a very clear cut definition in every step. Each of its step and their inputs and outputs should be very clear and must lead to only one meaning. Okay, must lead to only one meaning. That is called as definiteness. When we'll go further, you'll understand it better. Second is input. An algorithm should have zero or more well-defined inputs. Input means what should be the input, what should be the value range of it, what should be the data type of it, what way it should be inputted. All these things should be given. This what way in the sense either you can initialize them in the program or you can enter them into with the help of scanf. Okay, so an algorithm should have zero or more well-defined inputs. Output. An algorithm should have at least one output. Okay, and output means output should be such that it should match the desired output. It should match the desired output means towards the solution. It should lead us to the solution. Okay, so this is important. Then we go for next one, finiteness. Finiteness. Algorithm must terminate after a particular number of steps. Finite number of steps. You may be using loops into it. Then these loops should be defined such that at a particular point of time it will be terminating. It will be reduced. Otherwise, your program will go into infinite loop and will never stop execution. You must have experienced in C programming once you uh, write a program, it the screen will go on printing the output. That is, you enter into an infinite loop. Your algorithms are not getting terminated. So finiteness is another thing which you'll have to take care. Most importantly most importantly effectiveness of the algorithm. Every instruction must be very basic so that it can be carried out, and it should be feasible with the available resources. Instruction should be very clear, very small, very basic, and should be feasible with the available resources. Means whatever resources you have, it should be matching with that. It should not be out of the resources, or it should not ask for any other resources which we are right now not having. Okay, so definiteness. Don't get confused in definiteness and finiteness. Definiteness is making the algorithm clear and unambiguous. Finiteness means terminating the algorithm after a particular step. Input, output, and effectiveness. These are the 5 basic characteristics of an algorithm. This forms a very important question as far as your university exams are concerned or any of the exams are concerned. This question will definitely be asked in PMDS. Now, how to write an algorithm? There is, we must understand the first point, there is no well-defined standard for writing an algorithm. Okay, it is just a logic design. It is just logic building. You can write it by your own. One algorithm can be, or one solution can be obtained with many ways. So there is no well-defined standard for writing an algorithm. Rather, it is problem dependent or resource dependent. Whatever problem you have, if it is leading to a solution, algorithm is correct. Or whatever resources you have, it is leading to a solution, then it is okay. So it is either problem dependent or um, resource dependent, and algorithms are never written to support a particular programming code. It is written in general. Okay, you can convert it into any other language. Okay, so it is not written for a particular programming code. Second thing you need to understand is it can use the constructs which are used in the uh, basic programming language. Every programming language have loops. Every programming language have flow controls like do, for, while. These loops are there, or flow control like if, else, switch, case. These are there. So algorithm can use these common constructs. So you can make use of these common constructs while writing an algorithm. Algorithm writing is a process and executed only after the problem domain is well defined. Once you are clear with the problem and the solution uh, for it, then only you can start writing an algorithm. Algorithm, again I am repeating, algorithm is not a program. Algorithm is not a program. And most importantly, we are writing an algorithm to get a solution of a given problem, and a problem can be solved in more than one ways. So there are different approaches. So we can write number of algorithms for a single solution. So is it clear, और यह बहुत ज़्यादा मुश्किल हो रहा है आप लोगों के लिए समझने के लिए? It's a little theoretical part. Are you understanding it? This prompt? Yes, I'm happy to see that you are understanding. It's little theoretical, but it's very important. Okay, so this is the way you can write an algorithm. So ultimately, you can best way think that there is no particular way to write an algorithm. You have a liberty to write algorithm by yourself. We'll see a small program or a small algorithm. Design an algorithm to add two numbers and display the result. Probably this sounds very basic to you, or you may think that you have done better programs than this, but this is a foundation and we are going for it. So design an algorithm to add two numbers and display the result. We'll go for two ways to write this algorithm. In the first method, uh, we are writing stepwise. Step 1 start, step 2 declare three integers a, b and c. So what for we are declaring a, b? A, b will be the two numbers which will be inputted, and c will be the resultant, that is the sum of two numbers. Then define values of a and b, add values of a and b, store the output of step 4 to c in the variable c, and then print c. Okay, this is our uh, algorithm. It's quite simple, very clear. Is it following the all the properties or characteristics of an algorithm? Yes, it does. Okay, it is unambiguous. There is no instruction in this algorithm which is ambiguous or leading to two different meanings. The input is clear, output is clear. It is getting terminated once you have stored the output in the variable c and printed it. It is also effective, and with the available resources it can be executed. So last step is stop. So these are the 7 steps we are writing in method 1. This is one way of writing it, but can we have another way to write the same problem statement? We may have. As per my understanding, okay, I'll write a program, get values of a and b. I'll not specially mention declare three integers. If I am a good programmer, I can directly say that get values of a and b. It is understood that a and b has to be declared. C is equal to a plus b and display c. Okay. So this is also another way of writing a program. This is also following all the characteristics of the algorithm. It is again unambiguous, input is clear, output is clear, everything is well defined in this case. So we are going to, we can write two different algorithms for the same problem statement, right? So algorithm is written in this way. This step 1, step 2, step 3 is optional. You can either write it or you can skip it. There is no harm. So this is the way you can write an algorithm. Probably this sounds simple, but yes, you may need to go for it. We'll try to go for one more algorithm, but here we'll not have two different processes, but here we'll see how we can generate a pseudocode algorithm and a flowchart. Write an algorithm to determine students' final grade and indicate whether it is passing or failing. See, if you are facing some doubt, please post it in the chat box so that I can answer then and there only. So if you are facing some problem, please let me know. Uh, Write an algorithm to determine the student's final grade and indicate whether it is passing or failing. The final grade is calculated as the average of 4 marks, 4 different marks. So, how I can analyze this problem? Write an algorithm to determine student's final grade and indicate whether it is passing or failing. final grade is calculated as the average of 4 marks. That means my what will be my input? Input will be the marks of 4 different subjects. Okay, what is my output? It's the grade of student whether he has passed or failed. I need to decide the passing range. It may be 40, 50, whatever is there. And what will be the calculations? Finding out the average, checking it whether it falls in the pass grade or fail grade, and print the message accordingly. This is what the analysis of this problem. So pseudocode says that input a set of 4 marks, means marks of 4 subject. It says that calculate the average by summing and dividing it by 4. So put the sum of 4 marks together and divide it by 4. And if average is below 50%, say fail, or if it is above 50%, say pass. This is the pseudocode. Okay, this is very much like English. This is very much understandable to any layman who understands English. Okay, this is the way we are going to find out. But algorithm is little refinement of the same. Algorithm is refinement of the pseudocode, which will appear something like this. Step 1 is input M1, M2, M3, M4, the 4 variables. So that we are going to declare in the program. Then another variable grade is the average of it, sum divided by 4. And as we said, the programming constructs like if, else, or loopings can be directly used in algorithm. If grade is lesser than 50, then print fail, else print pass, and end f. So this will be a better uh, instruction set for me to get converted into a program than the pseudocode. Okay, pseudocode is not that clear, but now this is very clear and effective, so that it is easy for me to convert it to a program. Okay, so now here what particular thing you observe in previous and previous algorithm, here whatever algorithms are there, they are going to start from step 1 and will lead to the last step in a very sequential manner. Okay, the control is moving in a sequential manner, whereas what's happening here, the grade will be calculated. If grade is say 70, it is not going to if grade is coming out to be 70, it is not going to print this message, or it is not going to touch this line at all. Okay, the control will be directly passed to this statement. Are you understanding me? If grade is 70, and if the grade is 50, if the grade is 40, what will happen? This statement will be executed and this statement will be skipped. This will be skipped. See, this is happening in this particular program, that control is getting moved from one place to another, or probably it is keeping some lines based on the condition. Okay, so or based on the decision structure. So this is not the sequential algorithm, but it takes help of some decision making construct, and decide to skip a particular line of code and decide to execute a particular line of code. So this is different than previously what I was seeing. So there is a need to maintain the flow of this algorithm. Then what we are going to do? This image is called as flow chart. This is giving you the control of your uh, this is giving you the control of your program. So start we are going to move to the next statement, that is input M1, M2, M3, M4. Again a sequential statement that is immediately to be executed after that is finding out the grade. But if grade is formed, and if grade is above 50, then we are going to execute in this way. Okay, yes. uh, if grade is less than 50, then we are going to yes, this is the yes part. If grade is less than 50, then we are going to output fail and come to stop. This entire part, this entire part is, sorry, this entire part is skipped. This entire part is skipped. Whereas if the no condition is there, then at that moment, this part will be executed and this part will be skipped. Okay. So this is the way we are going to draw a flow chart. So this is the pseudocode, this is the detailed algorithm, and this is the third step, that is flow chart. Is it clear till now, whatever we have learned? Uh, Sir, what is end if? End if is the end of if loop. Means see, when if will be having grade less than 50, say 40 is the case, it will print this or it will print this, and then this is the end if. So it should come out of this once this statement is executed. Any one of this statement is executed. So this is the end of end if construct. This is the end of if construct. Okay. Okay, Ashwin. I think I made it clear. Okay. Is it so? Any doubt till this? Any doubt till this? The first part is pseudocode, then the detailed algorithm, then the flow chart. We have not yet reached to the program. We'll see it later. First, these things need to be clear. So, is it okay with you? Is it clear? Please prompt.
Yes, sir.
Fine. We'll continue our discussion. So, this is the flow chart and how this flow chart should be generated, that we are going to see now. What is a flow chart? The formal definition of it says that a flow chart is a diagram that depicts the flow of a program. Okay. Another definition says that flowchart is a type of diagram that represent an algorithm or process showing the step by step as boxes of various kinds and their order by connecting them by arrows. Yes, how the flow is going to happen, it will be given with the arrows. Okay. And the third definition says that flowchart or a flow diagram is a graphical representation of a process or a system that details the sequencing of steps required to create the output. So ultimately, what we can say that it is a diagrammatic representation of the flow of algorithm. Okay, flow of algorithm. So this is a formal definition of flow chart. See, this is another flowchart, a flowchart for adding the integers from 1 to n number of integers I want to uh, input. Okay, so here you can see, here you can see there is a start option. Then from start, we are moving to sum equal to 0 because initially no number is added. 1 to n means first number to be added is 1, and then n we will define maybe as 10, 20, 100, whatever you want to go for. And you'll just go on checking. If n is not reached, you are going to execute in this loop. Okay, and see, you are going back again. You are going back again. So this is the way you are going to execute this particular problem. And once n value is exceeded, you are going to display the sum and you are going to stop the program. Okay. So this is the way you can write an algorithm, but this was not my intention to show this. Uh, See here, there are different boxes. You can see the start and stop box, which are little rounded boxes. Then you can see these boxes as rectangular boxes, a diamond box, a parallelogram, all kind of things are available. So there are rounded rectangles or ellipse. These ellipses are used to denote the begin and end of any a program or a function or a procedure. Okay, start and stop or begin, end, anything you can write. So they are rounded rectangles or elliptical boxes are used for that. Some rectangle boxes are there which are used for processing statements. So these are the calculations: sum equal to 0, x equal to 1, sum equal to sum plus x. These are the processing statements. So rectangular boxes are used for that. Diamond boxes, diamond shape boxes are used for especially decision making. Then you have parallelogram, which are used for inputting a value or displaying a value. That means, in very simple, we can say that the statements which are interacting with the console, maybe a keyboard or a screen, those will be put in a parallelogram. The arrows are going to show the flow of program. So what way the controls will be passed. So these are the different symbols which are used in flowchart. Thus, we'll just have a look of different symbols which are used for different purposes. So these are the most common flowchart symbols. There are many, but we'll right now understand few. The first one is the terminator symbol, the rounded rectangles or elliptical boxes, begin and start. Then the decision making, any, it may be if loop, it may be for loop, wherever you are checking some values, this rectangular block has to be used. It can lead to yes or no, this kind of outputs, and which will give me the correct way to control the flow. The process, that is calculation, is can be done in rectangular boxes. If you are writing the output into a document or taking an input from a document, this kind of symbol will be used. If many documents are used, this will be the storage, internal storage, database, tape data. This you are not dealing actually. Input or output. Scanf printf statement need to be written in parallelogram box. Display statement, manual operation, merge operation, manual input, all these things we'll see as and when we'll proceed. Connector, if the flowchart is going into second page or you want to connect one function to another, this kind of connectors will be used. So these are the overall flowchart symbols which we can use for drawing a flowchart. Okay, I'll move a little faster in this. There are different sequence, there are different options in a program. One is sequence, a series of actions which are performed in the sequence, which will be placed in this way. There is, you can see that there is no decision box, there is no yes or no. We are directly moving from one instruction to another. So this will may be a sequence box. Here you can see the start, procedure box, and the input output box. You can go for a decision structure where one of two possible actions need to be taken. So depending on the condition, so this will be the way you are going to work on this. If yes, this will be the action taken. If no, this will be the action taken. So your decision box will look something like this. Repetition structure. A repetition structure represents part of the program that repeats. Means while loop, for loop, you are repeating a particular statement. So this will be the way it is going to happen. So it will, the value will be checked. If it is yes, the process will be executed. Again, the value will be checked. Okay. If condition is still true, the same is going to happen. Still true, same is going to happen till we have the condition false. Once condition is false, it is going to move to the next statement. Okay, this is a repetition structure. The case structure, switch case construct, you have already used, where one of the several possible action need to be taken. Means it may have different values, 4-5 values, and only one action has to be taken. So in that case, the output will be looking something like this. Like if the decision produces this value, it is going to take this or this or this or this. It is not the case that all four or any two will even be executed. Any one of these four will be executed, and then it is going to lead to the next statement once this is executed. So if this is executed, all these three the will not be touched at all. Okay, it is directly going a skip. Will be skipping all these three and moving to this one. So these are the case structures. There are some examples of C uh, of a flow chart. So these are different flow charts available. I'll put this PPT uh, on the Moodle website. You please, I hope everyone has joined Moodle website. I haven't checked the count. I'll put this PPT on that, and you can just go through it. Fine. So this was a discussion towards algorithm and flow chart, which is really very important to understand. It was little faster from my side. I request all you people to again go through this PPT once so that the job will be clear. And now whatever assignment problems you are supposed to do, if you are inputting these two things also, I can give you more time. Those who really wish to practice this, means I expect everyone to practice this, and I can extend the date of submission of uh, assignment by a week, where for every program you'll have to write an algorithm, a flow chart, and a program. Okay, so that will score you double the marks whatever is being allotted for the assignment. Okay, am I clear? What I am saying is I'll extend the date by 1 week, and I want for every program you are supposed to write an algorithm and uh, flow chart, for which I'll double the marks of every problem. That is, if it is 5, I'll give it 10, and if it is 10, I'll give 20. So I'll post this on the Moodle website, and I hope this was clear, and I'll I'll take leave now. So thank you very much for joining the class. Please, you people, please again go through this PPT and make the doubt clear. If you have any doubts, do ask me either on WhatsApp or in the next lecture. Fine. See you in the next lecture. Thank you. Bye.